So number 13 is kind of a weird question. It's asking you to use ratio test on a series, but it already gives you some previous information. So it says that a sub n plus 1 over a sub n already converges to a value of 1 over 8. But then it gives you another series with a sub n tacked on and another n to the 7. And it says prove using ratio tests whether this converges, diverges, or is inconclusive. So all we're going to do is we're going to take this series and let's apply ratio test to it. And let's see what we get. So we already have this information, but this information doesn't really do us any good right now. So first off, by applying ratio test, maybe we can make some sense of it. So ratio test, again, it just says that a sub n plus 1 over a sub n, the limit as n goes to infinity, will give us some value of L. So if I go ahead and plug this in for this series, don't get these a sub n's confused with this a sub n. This is our new term that we are going to plug in here. So by plugging it in and taking the limit as n goes to infinity, I end up with n plus 1 to the 7th times a sub n plus 1. So if I want to find a sub n plus 1 of this a sub n, all I do is I just plug in n plus 1. So whatever this series is, we don't know what it is, but we just know that a sub n plus 1 over a sub n does converge to 1 over 8 in this case. So that's my top. And on the bottom, I just have n to the 7th, a to the n. Okay, so I have these two terms here. I have a sub n plus 1 over a sub n. Well, I already know that the absolute value of a sub n plus 1 over a sub n converges to 1 over 8, because that's what I was told originally. So I know that this whole term right here just goes to 1 over 8. Now I just need to figure out what these terms are going to do as n approaches infinity. Well, I know with polynomials that if I take the limit of them as n approaches infinity, well, first off, I guess I'll factor it out. So I have a 1/8 that's kind of sitting out front now, and I have an n to the 7th plus a bunch of additional lower order terms. Again, I don't care about those lower order terms because n to the 7th is the dominating term in the polynomial. Same thing on the bottom, I have an n to the 7th. I don't have any additional terms after that, but because I have n to the 7th over n to the 7th as the leading terms of my polynomials, the whole coefficient just goes to 1 as n goes to infinity. So this term becomes 1. So my limit as n approaches infinity for this ratio test becomes just 1 over 8. Now according to the rules of ratio test, 1 over 8 is less than 1, so therefore this series should be absolutely convergent. And that would lead the answer to be C.
The Teaching Center, UF's Learning Resource Center.